Let's move to our next topic, that is factorization. On last turn we have studied about algebraic identities. Now it is time for factorization. Factorization, if we define the factorization, then we may say that expressing in a form of factors which can't be further which can't be further reduced. That means we are changing in a form that we are changing in a product of factors that are not further reducible. That means irreducible forms. We have to convert the given expression in irreducible forms. Like if we have x square plus 5x plus 6, then we can further reduce it and it will be given by x plus 3 into x plus 2. That is not further reducible. So we have converted the given expression x square plus 5x plus 6 into irreducible forms. For example, if we have 8a cube plus 4a square plus 12a, then by taking the common 4a from all the terms, we have 2a square plus a plus 3. Now we can't further reduce it, so they are the terms, they are the factorization. If we have ax plus by plus bx plus ay and we have to factorize it, then we will write it as ax plus ay plus bx plus by. Now we have a common from both the first terms and b common from both the last terms, and we are left with x plus y into a plus b. This is our factorization, final factorization. For example, if we have given an expression like 27x cube plus 8 plus 54x square plus 36x. Now to factorize it, we have to look at the expression. By looking at the expression, we will say that we have to use identity here. Identity, which identity will be used here? As we have studied about all the 10 identities, now from those 10 identities we can see that there are 4 terms. If there are 4 terms, then identity, that is, we have studied a plus b whole cube. In a plus b whole cube we have 4 terms, so it may be a plus b whole cube. Let's check whether it is a plus b whole cube or not. Then we may write the first term as 3x whole cube plus 8 as 2 cube plus 3 a square, that is 3x whole square into 2 plus 3a b square. It will be given by a plus b whole cube, that means 3x plus 2 whole cube, or you may say 3x plus 2, 3x plus 2 and 3x plus 2. Now we cannot further reduce it, so it is the final factorized solution. Let's see some other problems. Like if we have given to factorize a square plus b square plus 2ab minus 1, so by looking at it we can write it as a plus b whole square minus 1, or we have studied about x square minus y square, so it will be a plus b plus 1 and a plus b minus 1. Now we cannot further reduce it, so it is a factorized form. We have to factorize 54x cube x to the power 4 minus 16xy cube. First of all, we will see if we can have any common factors between them. By looking, we can say that we may have common factor as 2 is divisible by both the terms, so 2 is common and x is also common, so we are left with 27x cube minus 8y cube. Now it is the form of a cube minus b cube, clearly we can see. So now we can reduce it as 2x a cube minus b cube. The formula for a cube minus b cube is given as, this is a cube minus b cube. The formula for a cube minus b cube is a minus b, that means 3x minus 2y into a square, that is 3x square, plus ab, that means 3x into 2y plus b square, that means 2y whole square. So we have 2x into 3x minus 2y into 9x square plus 6xy plus 4y square. Okay, for example, let's solve some more examples. Like if we have given x raised to the power 6 minus y raised to the power 6 and we have to solve it, then we may write it as x square whole cube minus y square whole cube. Okay, now we have the identity a cube minus b cube. By the identity a cube minus b cube, we have a plus b, a square minus ab plus b square. Okay, now we cannot further reduce it, so it is the reducible form, that is the factorized form. We can write it as x square minus y square, a minus b, a square plus a b plus b square. Now by looking at this, we have a square minus b square identity, that is a plus b into a minus b. Now by looking at this expression, we should have some thing to solve it. We may write it as x square plus y square whole square minus x square y square. Okay, so it will be now given as x plus y, x minus y, and this is two factors, a square minus b square, that is given by a plus b and a minus b. Okay, so we have four factors that are not reducible. We can solve it by other method also, like we have x raised to the power 6 minus y raised to the power 6. Now we can write it as x cube square minus y cube square. Now it is in the form of a square minus b square, that can be solved by x cube plus y cube and x cube minus y cube. Now we can solve both the terms, like this is x cube plus y cube, this is given by x plus y into x square minus xy plus y square, and this is x cube minus y cube, this is x minus y, x square plus xy plus y square. So we will have finally x plus y, x minus y, x square plus xy plus y square into x square minus xy plus y square. Okay, now the next topic we have to study about is relationship between zeros and coefficients of a quadratic polynomial. Relationship between zeros and coefficients of quadratic polynomial. As we have studied so far that a quadratic polynomial px is given as ax square plus bx plus c, and we have two zeros of it, that is alpha and beta. Now we have to maintain a relationship between alpha, beta and a, b, c, that are the coefficient of the quadratic polynomial. Now to understand it, let we have two zeros of the given quadratic polynomial, that is alpha and beta. As the alpha and beta are zeros of the given quadratic polynomial, so at alpha the value of polynomial becomes 0, and at beta this is also 0. So we may say that alpha and beta are the zeros of the given polynomial. If alpha and beta are zeros of the given polynomial, then x minus alpha and x minus beta are the factors of the given polynomial, as you studied in factor theorem. So x minus alpha and x minus beta factors of the given polynomial. So we may write the given quadratic polynomial as k x minus alpha x minus beta, that was originally as ax square plus bx plus c, or by further solving it we will have k x square minus alpha plus beta whole into x plus alpha beta is equal to ax square plus bx plus c. By comparing both the sides, we will have that the coefficient of x square are equal on both sides, so k is equal to a, and minus k alpha plus beta is equal to b, and also k alpha beta is equal to. Suppose we have to find the value of alpha plus beta, then we may say that the value of alpha plus beta is given by minus b by a, and the value of alpha beta is given as c by a. So we may say that the sum of the zeros is equal to minus of coefficient of x upon coefficient of x square, and product of zeros is equal to constant upon coefficient of x. We can use this relationship in examples, in questions, in problems that we have given. Now, as we have studied about quadratic polynomial, let's see if we can maintain a relationship between zeros and coefficients of a cubic polynomial also. So the next topic is relationship between zeros and coefficients of a cubic polynomial. Let's we have a cubic polynomial as p of x is equal to ax cube plus bx square plus cx plus d. As it is a cubic polynomial, so we may have three zeros of it that are alpha, beta, gamma, assume. Now again, as they are the zeros of the given polynomial, so p of alpha and p of beta and p of gamma all will be equal to 0, or we may say that x minus alpha, x minus beta and x minus gamma are the factors of the given polynomial, given cubic polynomial, or we may write them as px is equal to k x minus alpha, x minus beta, x minus gamma. Okay, and the original polynomial was ax cube plus bx square plus cx plus d. Again, by comparing, we will have that alpha plus beta plus gamma is equal to minus b upon a. Sum of product of pairs, that is alpha beta plus beta gamma plus gamma alpha is equal to c upon a, and also alpha beta gamma, that is product of the zeros, is equal to minus d upon a. Okay, let me have some examples on the given relationship. Write down example 1. If the square of difference of the zeros of the quadratic polynomial px is equal to x square plus kx plus 45 is equal to 144, then you have to find the value of k. See, as we have, let's assume the zeros of the quadratic polynomial is alpha and beta. Then we may say that alpha minus beta whole square is equal to 144. Now the difference of the two roots will be 12. As the difference is 12, now we may find the value of alpha plus beta whole square, that is given by alpha minus beta whole square minus 4 alpha beta. Okay, or we can say that alpha plus beta whole square plus 4 alpha beta is equal to 144. Now, as we have studied about the relationship between zeros and coefficients of the given polynomial, then we may easily say that the alpha plus beta is equal to minus k. By substituting the value we will have, and also alpha beta is equal to 45. Substituting the value we will have minus k whole square minus 4 into 45 minus 144 is equal to 0, or you can say that k square minus 324 is equal to 0. From here we will have the value of k as plus minus 18. Let's do one more example. We have to find the zeros of cubic polynomial x cube minus 5x square minus 16x plus 80 is equal to 0. We have given the condition that its two zeros are equal in magnitude but opposite in sign. As we know that it is a cubic polynomial, so alpha plus beta plus gamma is given by minus b upon a, that is 5, and alpha beta plus beta gamma plus gamma alpha is given as minus 16, and also alpha beta gamma is given as minus 8. Now, as we know that the two zeros are equal in magnitude opposite sign, so if a root is alpha, then other root will be minus alpha, and the last one is gamma. Let us assume. So alpha minus gamma plus gamma, alpha minus alpha plus gamma is equal to 5, or we may say that gamma is equal to 5. Now we have find one root, that is gamma, that is equal to 5. Now by the third equation we have alpha into minus alpha into gamma is equal to minus 80, or we may say minus alpha square into 5 is equal to minus 80. From here we will have the value of alpha is equal to plus minus 4. So the three roots are 4, minus 4 and 5.